Over 100 times every year, the internet physically breaks at the bottom of the ocean. A ship's anchor, a fishing net, even an earthquake can sever a subsea cable. In that instant, the internet's hidden backup systems kick in, rerouting traffic. But the cable still needs to be repaired, by hand, in the middle of the ocean. This is one of the most extreme engineering missions on Earth. Today, we follow a cable ship on a mission to mend the internet. A subsea cable is a miracle of layered protection: glass core, steel armor, copper, polyethylene. A break often happens in the glass core, invisible under the armor. Fishing trawlers can snag cables in shallow water, pulling them off the seabed. In deep water, underwater landslides can bury or snap a cable under immense pressure. The cause is quickly identified, and a repair mission is triggered. Network operations centers alert the nearest cable ship to the fault. The first step: locate the exact break point. Shore stations send pulses of light down the cable. An optical time domain reflectometer measures the faint reflection that bounces back from the break. Just like radar, the time delay gives the exact distance to the fault. Combined with GPS cable route data, the fault is pinpointed to within a few meters. Even underwater canyons and mountains are mapped to plan the recovery. The ship is given a precise coordinate, and the crew plots the course. A specialized cable repair ship sets sail. On board are huge tanks of spare cable and a team of engineers. The bridge uses dynamic positioning, thrusters that hold the ship exactly over the fault. Inside, the ship is a floating factory, storage tanks, a jointing lab, and a giant bow sheave. On deck, the crew prepares the grapnel, a massive multi-pronged hook. And a remotely operated vehicle, or ROV, is ready to work in the crushing deep. After a few days at sea, the ship arrives on station. The real work begins. The bow sheave lowers a steel wire. At its end, the grapnel hook, descending into darkness. The ROV dives first, scanning the seabed with powerful lights, locating the damaged cable. Then, the grapnel is dragged across the seafloor, a process known as grappling. When the hook snags the cable, the ship's tension alarms spike. They've got it. The crew monitors the tension, careful not to snap the wire under the strain. Slowly, the cable is lifted off the seabed, its broken ends rising toward the surface. The cable rides up over the bow sheave, water streaming off, and is brought onto the deck. The crew carefully coils it into a storage tank, inspecting for damage. Both broken ends are cut clean with hydraulic shears, removing the ragged part. Now both ends are secured on deck. The ship has become a temporary bridge in the circuit. A quick electrical test checks that the copper conductor is intact. It is. The cable is ready to enter the heart of the ship, the jointing room. Inside the jointing room, it's a surgical environment. Technicians wear clean suits to avoid contamination. Each glass fiber, thinner than a human hair, is aligned and fused with an electric arc. The splice must be optically perfect. Any imperfection causes signal loss. A protective sleeve is heat shrunk over the splice, then the steel armor wires are rewrapped. The copper conductor is soldered, and the entire joint is encased in a watertight overmold. After several hours of meticulous work, the cable is whole again. Shore stations run final tests. Pulses fly through the repaired section without a glitch. The cable is paid back out over the bow sheave, descending to the seafloor. The ROV follows it down, using a jetting tool to rebury it safely under the sediment. On network screens, the fault clears. Internet traffic returns to its normal path. Somewhere, a video call reconnects, a stream buffers, a page loads, all because of this invisible fix. The ship sails home, mission complete. Another break will come, and they'll be ready.